All right, greetings everyone. Welcome to the first part of the video for section 5.3, continuing on with our study of circles and points. We're going to look at points on circles and relate that to some concepts that I think when people think of trig, this is a little bit more traditionally what they think of, or trigonometry I should say. Okay, so we're going to start by talking about points on a circle using what we're going to call sine and cosine. And I know that for some of you, if you've studied trig before, when you hear those terms sine and cosine, you're going to think of them, or you often think of them in terms of right triangles. However, for our purposes, for now, we're going to think about them a little bit differently. So we're not going to think of them in terms of right triangles yet. We will get there. So what I'm going to do to kind of explain what's going on here is draw a picture. So draw some coordinate axes, add in a circle here centered at the origin. So the center of that circle, even though it's a little offset, is supposed to be the point 0, 0 there. I'm going to select a point on that circle. So say this one right here. We'll call the coordinates of that point x comma y. And then note that the radius is going to be the distance from the center of the circle out to that point xy. So based on this conception here, then we're going to define something called the sine of the angle to be the ratio of that value y over the value of r, the radius. Okay, so sine will be y over r. And I should also add in here the angle theta. So we've talked about angles being in standard position. So if we think of starting there on the positive part of the horizontal axis and rotating counterclockwise to where the radius is, we'll call that angle theta. And so more specifically, what we're talking about here is the sine of that angle theta is going to be given by the ratio of y over r. Similarly, the cosine related to that angle theta, so cosine of theta equals the ratio of x over r, as we see there. Okay, and one thing I do want to point out, something I hear from students sometimes is, so these symbols here, or this notations looks like sin and cos. Okay, they do stand for sine and cosine. So when we say them, we say sine of theta or cosine of theta. We don't say sin or cos. I hear that sometimes from folks. Okay, so using these ideas, and in particular these formulas here for sine and cosine, let's do some problems. So we're asked here, using that information, to find the cosine of pi over 2 and the sine of pi over 2 in what's called the unit circle. Now notice in this case, the angle, pi over 2, okay, well that's in the place of theta, so that's our theta. So what we're really trying to find is cosine of theta and sine of theta when that particular value for theta is pi over 2. We can also use our conversion factors for converting between radians and degrees to see, if we multiply this by 180 degrees over pi, cancel some things out here, we see that the angle pi over 2 is actually the same as 90 degrees. Okay, so we're dealing with a 90-degree angle here, but we're going to think of it in radians as pi over 2. And then we're also told we're dealing with something called the unit circle. So what is that? I'm again going to draw the picture we just had. Okay, so coordinate axes, we're going to have a circle centered at the origin. So the center here is the point 0, 0. And then a unit circle, or the unit circle, is going to be a circle for which the center is that point 0, 0. And then the radius, so the distance from that center to the outside, is a constant value of 1. So anytime you have this, again, circle centered at the point 0, 0, radius of length 1, then we are talking about the unit circle. Okay, so now in this unit circle, I'm going to deal with an angle of pi over 2 radians, or 90 degrees. So if we think again is starting here at our positive part of our horizontal axis, if we rotate around about 90 degrees, or sorry, exactly 90 degrees, we're going to end up on this vertical line here. And basically what we need to do then is find the coordinates of this point right here. Okay, and the reason we need to do that is because recall from what we just saw, the cosine of pi over 2 is going to be equal to the ratio of x over r, and the sine of pi over 2 will be equal to the ratio of y over r. So we need the points x and y there, so we can plug them into this formula to find the sine and the cosine. Okay, so let's think about this. First of all, notice that this green line I've highlighted here goes from the center of the circle to the outside. So it looks like it's a length of a radius, and as we see down below, the length of the radius here is 1. So that line is really going up 1 unit from the center. Also notice that at this point we've highlighted here that we're trying to find the coordinates for, right? We have not moved left or right at all, okay? So that tells me that the input value there, the x value, would be 0, because from the origin we have not gone left or right at all. But we did go up that 1 unit, the length of the radius, so that would be the point 0, 1. So now that we have this, we have our coordinates for x and y. We can plug that information in to our formulas over here. So for cosine, we'll have the value for x, which is 0, divided by the length of the radius, which, like we just said, is 1. So we get 0 over 1, which is just 1. And then for the sine, we'll do the y value, which in this case is 1, divided by the length of the radius, which is also 1. So we have 1 over 1, which just gives us 1. And sorry, I said 0 over 1 was 1. That should have been 0 up here. I apologize for the mistake there. Okay, so we see that cosine of pi over 2, of the angle pi over 2, or 90 degrees, is 0. The sine of pi over 2 is 1. And notice an additional thing, because this is a unit circle, notice that the cosine value here ended up being the same as the x value, and the sine value here ended up being the same as the y value. That's really interesting. That might be something to keep in mind for the future. Okay, let's look at another problem. So here, now we're given an angle theta that's in a circle of radius 26. And we're given this time that the cosine is 12 over 13 and the sine is 5 over 13. And what we need to do is find the coordinate point on the circle that corresponds to the angle theta. So let's again draw a picture to see what's going on here. So I'm going to have my coordinate axis, my circle here. That was terrible. Let me draw another circle. That's also, oh my gosh, hold on, I'll get this. Okay, it's a little bit better. And so notice here they didn't tell us the angle. So we just know that this is rotating around some angle theta to a certain point. And we want to find the coordinate point on the circle. So basically we want to find the coordinates right here where that radius intersects the circle, those points x comma y. And all we're given are the sine and the cosine. Now, or and the radius. An additional thing to note about this is we're actually not going to find the measure of the angle theta. So you might think that maybe that's important here. It actually turns out we don't need that information to complete this problem. So here's how we can do it. Recall again from that slide we started with. We know that the cosine of an angle in a circle like this is given by the ratio x over r. And the sine value is given by the ratio y over r. Well, notice, again, we are given the value of the radius and the cosine and the sine. So we can use those in these equations here to solve for x and y. So for example, for the cosine, we know the cosine is equal to 12 over 13. So I can say 12 over 13 equals, we don't know the value for x, so leave that as a variable, over, we do know the value for the radius, right? That is 26. So then we can solve for the value of x here by multiplying by 26 on both sides here. Okay, that'll isolate our value for x. So have x equals, we can do some fraction reduction here. This will become a 1 and a 2. So it looks like we get x equals 24. And then do a similar process to solve for y. So again, we'll say our sine value, which is 5 over 13, is equal to the ratio y, we don't know, over the length r, which is 26. Can multiply by 26 again on both sides. And when we do that, we will end up with y equals, these will cancel. Looks like in this case we get 10. So x is 24, y is 10, so it looks like that would be our coordinate point here, 24, comma, 10. Okay, and again, notice that to do that, we did not have to know what the angle, what the angle was. All right, that's all for now. Thank you for watching.